All right, I've just got one more example, and then you need to do some practice. That's the only way to learn this stuff is to do practice. So in example 3, we're asked to write a definite integral to represent the area under the graph f of t equals e to the 0.5t between t equals 0 and t equals 4. All right. So just remember the area under the graph is the definite integral. So we're just basically being asked to find the definite integral from 0 to 4 of this function e to the 0.5t dt. Okay. So we need the antiderivative, right? So you look back at the back of the table in the last lecture, and you'll find that we need to take, if k is 0.5, then we take 1 over 0.5 e to the 0.5t. That's our antiderivative. And we're going to evaluate that from 0 to 4. Okay. So this 1 over 0.5 is really just 2. 1 over a half. It's a reciprocal of 1/2, right? So we just have 2 e to the 0.5, and we need to evaluate it at the upper limit of integration first, and then subtract 2e to the 0.5 times the lower limit of integration, which is 0. All right, so this just becomes e to the 0, which is 1. And so let's see, what do we have? We have 2e, and then we have half of 4, which is 2. So 2e squared minus 2. Okay, that would be the exact answer. You can see in a lot of these discussion questions, you're being asked for exact answers. So you can't just type it into your calculator and get a decimal answer. I want the exact answer. All right, so this is an exact answer. So if I wanted a decimal approximation, I could put it into my calculator and get 12.778. And then I could check my answer. I could use the integration function on my calculator then to actually check the answer, right? Because it's going to give me a decimal answer if I put it into my calculator. So, but this is the exact answer. All right, so that's all I have for examples. This is just more, again, you just need to practice this stuff. And so look ahead at the discussion questions, and I'll see you in class.